Hey everyone. So today we're going to be going over section 2.4, which is all about deductive reasoning. And our goal today is to be able to use the law of detachment and the law of syllogism. So deductive reasoning is the process of using reasoning logically from given statements or facts to a conclusion. So if you remember earlier, we had a reasoning called inductive reasoning. And inductive reasoning was based on patterns and observation. And from there, we would draw a conjecture, which could be true or false. Deductive reasoning, we're going to be using given information to draw a conclusion, which would be if the given information is correct, then our conclusion would have to be correct also. On this slide, we're talking about the law of detachment. So the law of detachment is a big one. It's half our goal for this lesson. And the law of detachment says, if the hypothesis of a true conditional statement is true, then the conclusion is true. And that actually makes a lot of sense. So if I have a conditional statement, if P, then Q, and I'm saying that this is a true statement. If P, then Q is true, and P is true, then Q is true. That's like me saying that I'm talking to a student, I'm like, hey, if you get a 95% on this test, then you will get an A. The student gets a 95% on the test. The conclusion would be that they get an A. Assuming that my conditional statement is true and they meet the condition, then the conclusion will happen. That is the law of detachment. So given that, if a student gets an A on a final exam, then the student will pass the course. So considering this is given, we are going to assume that this is a true statement. The other thing they tell us is that Felicia gets an A on her history final exam. So we're assuming that this is also a true statement because it was given to us. And they're asking, what is the conclusion here? Well, if a student gets an A on their final exam, P, then the student will pass the course, Q. Saying that Felicia met the criteria P, therefore, according to the law of detachment, Q must be true. So my conclusion would be that Felicia will pass her course. And this course is history. So Felicia will pass history. Example 2, if a ray divides an angle into two congruent angles, then the ray is an angle bisector. Then it says that ray RS divides angle ARB so that ARS is congruent to SRB. So what is our conclusion here? Okay, so we're saying that if a ray divides an angle into two congruent angles, P, then the angle is an angle, or the ray is an angle bisector, Q. And here we say that ray RS divides an angle into two congruent angles. Well, that's P. So my conclusion has to be Q, that ray RS is an angle bisector. Let's say that RS is an angle bisector. Example 3, if two angles are adjacent, then they share a common vertex. So two angles are adjacent, P. Then they share a common vertex, Q. And then it tells me that angle 1 and angle 2 share a common vertex. Well, that is Q. So what conclusion can I draw? Well, P implies Q. Q is true. And that is not the law of detachment, so I'm going to say no conclusion. No conclusion. Remember, the law of detachment says one and only one thing. The law of detachment says if P implies Q, and P is true, then Q is true. This is our law of detachment. The setup they're giving me here is not the law of detachment, and I don't know any other laws right now, so no conclusion. So our other key concept today is the law of syllogism. So this was the other half of what I wanted to understand today. So the law of syllogism, it says that if P implies Q is true, and Q implies R is true, then we can cut out the middleman and say that P implies R. So I always say that my parents are taller than I am, and I'm taller than my brother. Therefore, my parents are taller than my brother. If you know this term, it's almost like the transitive property. So an example is, if it is July, then you are on summer vacation. And if you're on summer vacation, then you work at a smoothie shop. So what conclusion can I draw? Well, I could say that if it's July, then you work at a smoothie shop. So they're saying P, Q, but Q implies R. Therefore, P must imply R. We're cutting out the middleman of Q. P implies Q, Q implies R, therefore P implies R. That is the law of syllogism. So in this section, we've got two laws. We've got the law of detachment and the law of syllogism. And when we're doing this chapter, those are the only two laws that we know. So if we can't use either law, then we are forced to say no conclusion. A big issue that I see teaching this chapter, people will try to use past experiences that they've had to draw conclusions in this chapter, but this chapter is really wanting to only use the law of detachment and the law of syllogism. Think about that episode from SpongeBob where Mr. Krabs tells SpongeBob to forget everything he knows except for fine dining and breathing. That's this section, except for it's law of detachment, law of syllogism. Example 4. So it says, if a figure is a square, then the figure is a rectangle. So if the figure is a square, I'll call that P. Then the figure is a rectangle. Well, that's true. And if a figure is a rectangle, Q, then the figure has 4 sides. So that is not being a square, that's not being a rectangle, so I'm going to call this R. So I've got P implies Q. I've got Q implies R. These are both true statements. Therefore, according to the law of syllogism, P implies R. So my conclusion would be, if a figure is a square, so if a figure is a square, then R, then the figure has 4 sides. Example 5. If you do gymnastics, so doing gymnastics, that's P, then you are flexible, Q. If you do ballet, well, ballet is not gymnastics and it's not necessarily flexible, so I'm going to say that this is R, then you are flexible, Q. So my statements are P is gymnastics, Q is flexible, and R is ballet. So I've got P implies Q. I've got R implies Q. And they want a conclusion. So the temptation is that maybe P implies R, but that's not correct. So using the law of detachment and the law of syllogism, I honestly have no conclusion. These terms do not line up. Law of detachment means P implies Q. If P is true, then Q is true. And the law of syllogism is if P implies Q and Q implies R, then P implies R. These are the only two setups I know how to deal with. And I don't have that setup, so my answer here is going to be no conclusion. Example 6. So example 6 is going to combine our law of syllogism and our law of detachment to make a single true conclusion. Again, detachment says if P implies Q is true and P is true, then Q is true. Law of syllogism says if P implies Q is true and Q implies R is true, then P implies R. So let's take a look at, we've got 3 statements. So we've got 1, 2, and 3. So for 1, it says if you live in Gloucester, that'll be P. Then you live in Ohio, Q. If you live in Ohio, that was Q. Then you live in the US, that's R. So looking at my first 2 statements, P implies Q, Q implies R. I can combine these to say P implies R. If you live in Gloucester, then you live in the United States. Now my third statement says that you live in Gloucester. That's P. So I know that P implies R. P is true. Now I know that the law of detachment says P implies Q. If P is true, then Q is true. But this still works. P implies R. P is true. Therefore, R is true. So my conclusion is going to be R. And R is that you live in the United States. So my conclusion is that you live in the US. And if you went out of order, you're actually still going to be okay. Like I can combine the first and third statement. So it says that if you live in Gloucester, then you live in Ohio. You live in Gloucester, therefore you live in Ohio. But then I also have the statement that if you live in Ohio, then you live in the United States. I already showed that you live in Ohio, therefore you must live in the United States. And we're going to get the exact same conclusion. So depending on if you want to use the law of syllogism first or the law of detachment first, you can draw this same conclusion. So lesson check. We're just using law of detachment and law of syllogism here. So number one, it says if it is Tuesday. So Tuesday is P. You will go bowling, Q. Then it says you go bowling. And they want to know what conclusion you can make. So P implies Q. Q is true. Therefore, no conclusion. The law of detachment does not work here. I know that probably 30% of people on the test, when we have almost this exact same question, are going to say that the conclusion is that it's Tuesday. But that is not necessarily true. For example, this person might be in a bowling league that bowls on Tuesdays and Thursdays. So just because they went bowling doesn't mean it was Tuesday. It might have been a Thursday. So this is why we can not go outside of the law of detachment and law of syllogism to make a conclusion. Gotta stick to what we know. Fine dining and breathing. So number two, if a figure is a three-sided polygon, then it is a triangle. So three-sided polygon, P, is a triangle Q. And they say that ABC is a three-sided polygon, that's P. So I've got P implies Q. P is true, therefore Q is true. So I'm going to say that figure ABC is a triangle. So more lesson check here. It says that if it is Saturday, then you walk to work. So being Saturday is P, walking to work is Q. If you walk to work, Q, then you wear sneakers. So I've got P implies Q, Q implies R, and what conclusion can I make? P implies R by the law of syllogism. So what is that really saying? It means that if it is Saturday, then you wear sneakers. So if it is Saturday, then you wear sneakers. And number four, what is the error in the reasoning below? And it says birds that weigh more than 50 pounds cannot fly. A kiwi cannot fly. So a kiwi weighs more than 50 pounds. Ooh, so what error are they doing here? So birds that weigh more than 50 pounds. That's going to be your P. Let me try to highlight in that color that we can see better. So birds that weigh more than 50 pounds, that's P. And what's my conclusion? What's R? They cannot fly. R. And then it says kiwis cannot fly. That's R. So I've got P implies Q. And then, oh, I don't know why I'm calling it R. So in this case, I guess it's P implies R. That's fine. R is true. So P implies R, and R is true. Well, that is not the law of detachment, so this is no conclusion. No conclusion. I don't know why I used R instead of Q, but it works. It doesn't matter which letters you use. And the last question on the lesson check, they're asking, how is deductive reasoning different from inductive reasoning? So they're both types of reasoning. They're both very helpful. Deductive reasoning is using given information. So they're telling you this is true, this is true, this is true, what can you conclude? And using preset laws, the law of detachment, the law of syllogism, we're drawing a conclusion based on given information. Where inductive reasoning, we're doing an observation. From what I observe, this is going to be true. Deductive reasoning gives you a concrete answer, where inductive reasoning gives you a conjecture, which might be true, it might be false. So I always like to say that deductive reasoning is math. When we're solving for a variable, we go through steps that we know, and we get an answer, and we say, based on this reasoning, this is the answer, we're done. Where inductive reasoning is a little more like science. In science, you run an experiment, you make a hypothesis, you test your hypothesis, and you repeat the cycle. So in science, sometimes we come up with results that are not true, and we disprove them later, and then we continue our process. We're observing. We at one point thought we couldn't split an atom, and then we learned, yes, we can. So it's not saying that one's better than the other. Math tends to be more hypothetical, where they give us some preset numbers, some preset rules, where inductive is a little more theoretical. It's based on my observation, this is what I think will happen. The more observation you have, the more certain you are about what you think. So that's how they're different. So closing thoughts on this section. Deductive reasoning is one of my favorite types of logic because we get very concrete answers. It's also a big reason why I study math. We use deductive reasoning a lot in math. And our next two sections are going to be super, super heavy on deductive reasoning. It's going to start looking maybe more like a little bit traditional math, like we're going to start seeing some numbers, we're going to start seeing some shapes again. But we're going to be using our deductive reasoning to show that answers are correct. I also, back in high school, I like to compete in mock trial where you are simulating a real court case. In those situations, you want to use proper logic and reasoning to prove your point. So this is a very important section. In fact, I like to think it's a very important chapter. I would go as far as to say it's probably the most important chapter in the whole year because this stuff is very applicable to the real world. It doesn't matter what subject you're doing, you can always use logical reasoning. And sometimes I feel like people don't use logical reasoning enough. They make up their own criteria. They're not following the law of deduction or detachment and the law of syllogism. They're just kind of doing their own thing and arguing based on feeling, where we need to really be able to think logically about things. So if there's any takeaway today, it's just logical reasoning is important. And I also think sometimes logic puzzles can be fun. So the more you do, the better you'll get at this and the faster it'll go. But we've got two more sections in this chapter, and some people are going to argue that they're the hardest section or hardest sections of the year because we're going to start doing proofs. But I find that with practice, these things make a lot more sense and they get a lot easier. So it's very, how much effort you put in will really determine how much you understand it.